Hello everyone and welcome to Algebra 2. Today we're going to be talking about 4-1 quadratic functions and transformations. Let's begin. First things first, let's talk a little bit about vocabulary and let's have a little bit of a review. Alright, so question 1. Circle the vertex of each absolute value graph. In this case, the vertex is always going to be that point in which it changes direction. So the point in which it changes direction for the first graph is obviously going to be in the dead center. Again, the same thing happens in the second one. It happens to be in the dead center of the graph as well. But it doesn't always have to be in the dead center because as you can see in the third graph, it's going to be the point in which it changes direction one more time. So we're looking at the point 2, -3. But today we're going to be talking about parabolas. So we're going to have things like the vertex, the axis of symmetry, quadratic functions. Those are going to be all things that we're going to be talking about. But a parabola is a graph of a quadratic function, a function of the form y equals ax squared plus bx plus c. A parabola is symmetrical around the axis of symmetry, which is a line passing through the vertex, which is very important for later on. A parabola can open upward or downward, as you can see in the picture right here. The very first parabola given is going to be opening upward. The second one's opening downward. Circle each function whose graph is a parabola. Well, in order for us to know if it's a parabola or not, it needs to show up as the y equals ax squared plus bx plus c form. And more importantly, it just really needs that x squared portion. Right, as long as the highest degree or the highest exponent that is given is a 2, it's going to create some form of quadratic function, also known as obviously a parabola. So looking at this 4 different functions that are given, the very first one does not represent a parabola or will not graph as a parabola, and the last one will not graph as a parabola because they do not have the x squared. However, the second and the third will. Now we have to cross out the function whose graph is not a parabola, which means that we're going to allow the parabola ones to be there, but we're also going to cross out, kind of like what we did in question 2, the ones that aren't supposed to create parabolas. Alright, so again, we're looking for the x squared. The very first and the third function that is given both have the x squareds, which means that the second and the fourth will not create a parabola. Great work. Problem number 2. Graphing translations of f of x equals x squared, also known as the parent function of the quadratic. Alright, so let's graph g of x, which equals x squared plus 3, and let's see how it's translated from the original parent graph of f of x equals x squared. Can you use the graph to the right for exercises 4 and 5? Well, so let's circle the ordered pairs of the solutions for g of x, and underline the ordered pairs with the solutions for f of x. Well, all we're going to be doing is just technically plugging everything in. So taking a look at all of these different points, they're going to give you either the f value and the f of x value, if it works, or it gives you the x value and the g of x value. Again, if it works. Now I'm going to tell you -3 and 0, if we plug in -3 into either of these, the g of x or the f of x, the outcome will not be 0 for either of them. So we know that that one's not going to work. But if I do plug in that -3, the f of x will actually work, because if I plug in the -3 and I plug in the 9 for the f of x, like I'm supposed to, I'm going to get a 9 has to equal a -3 squared. Now the thing is, you need to make sure you put parentheses because that will allow this to become 9 equals a -3 times a -3, which does in fact equal 9. So that is how that one works. If I do the 0 and -3, it's not going to work for any of them. 0, 0 will work for the f of x. 0 squared will equal 0. 0, 3 however, will work for g of x. So we can actually circle this one. So if I plug a 0 in, we'll get 0 squared plus 3, and that has to equal our 3. Again, we're just plugging in the x value and hoping that it matches our f of x, or in this case, g of x portion. and you'll get 0 squared plus 3 equals 3. Well, 0 plus 3 does in fact equal 3, and that's why it works. 0 and 9, none of them will work for 0 and 9, so we don't have to worry about that. 3 and 0. Well, if we plug in a 3 for any of them, our answer is not going to be 0. We're not taking away anything. We have 3 and 9. Well, if negative 3 works, then positive 3 will work for the f of x as well. For the same reasoning, 3 squared does obviously equal 9. And then we have the 3 and the 12. 3 squared equals 9, so if we add 3 to that, you'll get 12. So sure enough, the 3 and the 12 will work for g of x. Underline the correct word to complete each sentence. For each value of x, the value of g of x equals x squared plus 3 is 3 more than the value of x squared. Well, in this case, we're adding, so therefore it has to be more than. Less than would represent subtraction, which is something we're not doing. So the graph of g of x equals x squared plus 3 is a translation 3 units either up or down. Well, since we're talking about something vertical, it's moving up or down, I know that it's going to be as is. So this plus 3 must mean that it's going to be going up 3. So therefore, the graph shows that f of x equals x squared is going to end up being the blue graph, the original, down here. And we also should know that that's a parent graph because it's starting at the point 0, 0 and going up to the point 1, 1. Right? And we also have the g of x. Well, since the f of x equals the blue portion, the g of x must be the red, which is very true as well, because as you can see, it is in fact going to be increased 1, 2, 3, all the way up until you get to that g of x portion. Great job. Problem number 3, interpreting vertex form. What are the vertex axis of symmetry, minimum and maximum, and the domain and range of this function given right here? Well, if we were to compare y equals negative 2 times x plus 1 squared plus 4 with the vertex form, which is given right here, which should also look very, very familiar, the only difference, of course, having that square up in the top right corner, identify the a, h, and a. Well, let's identify the a, h, and the k. The a is that number on the outside, so the number on the outside that's given is a negative 2, so I'm going to put negative 2. However, everything done on the inside of the parentheses is always going to be its opposite, so that original h, which is now a positive 1, is going to become its opposite, so we're going to change that to a negative 1. Right? So remember to change it if it's on the inside of the parentheses. And last but not least, you have your k value, which is on the outside, which is always good, and we're just going to see what it is. It happens to be a positive 4, which means that we're just going to bring that down into our k value. Now, if we had to find the vertex of the parabola, it's simple. We just have to figure out what the h is and what the k is, which we already did. So our vertex is going to be at the point negative 1, 4. Now, if we go back to the beginning, we talked about the axis of symmetry being the line that passes through the vertex. Well, in this case, if we're passing through the vertex, we just have to figure out what the x value of the vertex is. And evidently, it's given to us. So the axis of symmetry is a line x equals negative 1, also known as the x of the vertex. Underline the correct word or symbol to complete each sentence. Well, since a is less than 0, in other words, negative, right, the parabola opens. Well, if it's negative, it kind of makes a frowny face, is how I always remember it. So it's going to be opening downward. Now, the real reason is because, again, since it is negative, you're going to be going farther and farther negative, which is why we have the arrows pointing downward, because that shows that it's infinitely going down. But again, frowny face makes it a little bit easier sometimes. The parabola has a maximum or a minimum. This is always backwards, though, with that frowny face idea. And the fact that, in this case, it's going to have a maximum. And the reason it has a maximum is because we can tell exactly the highest point that is given. You cannot tell me the lowest point because these arrows go on forever. Therefore, we know the highest point, so we call this a maximum. Now the maximum is going to happen at the highest point, which is going to be basically at the vertex, but more importantly, the thing that represents height is going to be the y values. So the y value of the vertex is going to be the maximum value. So in this case, it's going to be a maximum value of 4 when x equals, obviously, the -1 at the vertex. So let's circle the domain. Well, if I ever draw a parabola, I'm always going to have to put 2 different arrows going one to the left side and one going to the right. Well, if that's the case, then it's infinitely going to be going to the left and it's infinitely going to be going to the right, and they're always going to be connected. And therefore, it's going to be all real numbers. Every quadratic's domain will always be all real numbers. What about the range? Well, in this case, we have a maximum. We have a highest point, which means we have to talk about all the points below that point. Well, first things first, the highest is 4, so we know that we can rule out the -1, and we know that we have a maximum, so therefore we can get rid of all real numbers. But now it's either less than or equal to 4, or greater than or equal to 4. Well, if we're talking about all the points below 4, we have to do the less than or equal to portion. Now, they did make a little mistake here. They did put an x as less than or equal to 4, but since we're talking about range, that is the y value. So that is really supposed to be y is less than or equal to 4. Great work. Use one of the functions below to label each graph. Paying attention to these, we're just going to be doing simple translations of the parabola. So that means we're going to be talking about moving things by adding and subtracting. Now the thing is, if we're adding or subtracting on the inside of the parentheses, or if we're adding or subtracting on the outside. Remember, on the outside, like as you can see right here and right here, that is going to be a vertical translation, meaning it's either going to be going up or down. But more importantly, it's exactly as you see it. So a +3 means that we're going to be going up 3. A -2 means that we're going down 2. But the problem is, when you go into the inside of the parentheses, you have 2 different options. You have the -2 and you have the +1. But everything is always backwards. So if I were to think -2, I would normally think going to the left, but in this case, I'm obviously going to be going to the right 2. For the other one, we have a +1, which means normally I would think I'm going to the right, but in this case, I'm going to be going to the left. And that's how you kind of go about each and every one. So taking a look at this, we're going to start at the origin, and are going to notice that this vertex technically went to the left once, and then it proceeded to go down 1, 2. So which one shows going to the left once, and then down 2? Well, that's going to be the y equals the x plus 1 squared minus 2. Taking a look at the second graph, we just went down 1, so the only one that represents a vertical translation, just a vertical translation, is going to be this one, that y equals x squared minus 1. So I'm actually going to cross out this one as well as the previous one. We're going to put that down in the answer slot. So we get y equals the x squared minus 1. The next one, we just moved to the left 1, 2, 3, which means that we're adding 3 on the inside of the parentheses, which means we can eliminate this y equals x plus 3 squared. And then the very last one is the only one that we have left, which is the y equals the x minus 2 squared plus 3. But just to make sure, did we move to the right 2 units? Well, looks like we did. 1, 2. And then did we move up 3? So we got 1, 2, and then 3. And we're good. Problem number 4. Using vertex form. What is the graph of f of x equals 2 times the x plus 2 squared minus 5? Well, let's take a look at the steps to transform the graph of y equals x squared to give you the y equals the 2 times the x plus 2 squared minus 5. I'm going to notice we have 1, 2, 3 different transformations. Looking at the 3 different transformations, I can see that we have a vertical stretch because we're multiplying by something on the outside with a number that is larger than 1. We have a horizontal translation because we're adding or subtracting on the inside of the parentheses. And we have a vertical translation because we're adding or subtracting on the outside of the parentheses. So taking a look at that vertical stretch, we're multiplying by 2, so it's going to be a vertical stretch of 2. That horizontal translation is adding 2, so we're going to be going to the left 2. So I'll put left 2. And then the minus 5 on the outside means that we're going to be going down 5. So vertical translation down 5. Looking at choice A, it says we reflected across the x-axis. Of those 3 different transformations that we have, we never reflected. And if I actually shoot across to choice D, this one also says reflect across the x-axis, which is not true. So we either stretch by a factor of 2, that's correct, translate 2 units to the right, we translated 2 units to the left. So we know it's not choice B. So just to make sure, stretch by the factor of 2 and translate 2 units to the left and 5 units down. That is perfect. Now, how would that look? Well, if we didn't reflect across anything, we know that it's going to be a happy face or a parabola that's going upwards because we're not multiplying by negative. The A value is positive, so we can actually eliminate out the second and the third graph. Now, really, the only difference between the first and the last graph is one moved to the right and the other one moves to the left. And as we said before, we had to move to the left, so the first graph is the correct graph. Great work. Problem number 5, writing a quadratic function in vertex form. The graph shows the jump of a dolphin. The axis of symmetry is x equals 2, very important, and the height is 7, also very important. If the path of the jump passes through the point 5, 5, also important, what quadratic function models the path of the jump? Well, the vertex is going to be its highest point in this case, because it's going to be going up and then down, because that's how gravity works. And it's going to happen at the point, well, x equals 2 was the axis of symmetry, so x equals 2 is going to be the x value of the vertex, so we know that there's going to be a 2 right there, and then the height of 7 means that the highest point was 7, which again turns into the y value, because we're talking about height once more. You can actually see it on the graph as well. It's going to be 7 for that vertex. Well, if we know that, we know our h and we know our k value, so we can just plug them in. So let's substitute them into the equation. So we have y equals the a times the x minus our h, which becomes 2, squared, plus our k, which becomes 7. If we plug in all of that, we can then start substituting in our 5, 5 for the x and y. And the reason why is because 5 represents the x as well as the y in this ordered pair. So if we plug them in, everything should be able to simplify it down, and then we can eventually solve for the a value, which is that last little bit that we need. So I'm going to write down the original equation. So we have y equals the a times the x minus 2 squared plus 7. I'm then going to substitute in the 5. Now, normally I would put parentheses around everything, but those parentheses aren't going to matter anyway in this case, so I'm not going to worry too much about it. But we have a 5 minus 2 squared, so I'm going to bring this one out really quick. So we have 5 minus 2, and then it's going to be squared, which means that we have the same thing as 3 squared, which is 9. And that's exactly where they got this 9 from. We then have a 9 times the a plus the 7, so we're going to subtract 7 from both sides, and you'll get negative 2 equals 9a. We'll divide by 9, and you'll get that a is going to equal that negative 2 over 9. Now, The one thing that we always need to pay attention to is if we're ever talking about a quadratic function problem that represents gravity, meaning I'm throwing a ball, dropping a ball, a dolphin jumping through the air, something that's going up but it always comes down. Remember, it creates that upward and then downward motion of a negative parabola, which means our a value will always be negative. Basically, what I'm trying to say is if you end up with a positive number right here, check your work, because you messed up somewhere if we're talking about some sort of gravity type problem. Just as a little helpful hint. So we have to write the quadratic function that models the path of the dolphin, not the water. And the quadratic function that models the path of the dolphin, we're just going to put the x and y back into it. So we're going to get y equals, or f of x equals, both represent the same thing. They're just calling it a function of x. But f of x equals negative 2 over 9 times the x minus 2 squared plus 7. If you put the y instead of the f of x, everything is perfectly fine. And we finally made it, the lesson check. Alright, so let's power through. When does the graph of the quadratic function have a minimum value? Circle the parabola that has the minimum value. Now again, the minimum value means that it's going to have its lowest point, and you can tell me what the lowest point is. Alright, so right here, I can say with 100% certainty that 0 is the lowest point, because there is no part of the graph that goes below it. So that is its minimum. Whereas this one, this 0 is its maximum. But if you look with the arrows being on the bottom, we know that that's going to keep on going on forever and ever, meaning that we can't actually get a low enough number to be considered a minimum for this problem. Therefore, the first graph is going to be the graph that shows the minimum, whereas the second graph shows the maximum, it shows the highest point. The graph of y equals x squared is a parabola that opens upward. Right? It's a positive graph, which means both the arrows are going to be going into the positive direction. It also makes a smiley face. The graph of y equals negative x squared is a negative graph, which means the arrows are going to be going constantly straight down, which means that it's going to be opening downward, also known as that frowny face, because it's upset, it's sad, it's the negative version. So when does the graph of the quadratic function have a minimum value? Well, a minimum value will always happen when a is positive. In other words, when a is greater than 0, the parabola opens upwards. And that's it, everybody. I hope everyone has a wonderful day. Stay out of trouble. Don't do anything stupid. And I'll see you guys in the next one.